All right, let's get started.
Let's do
Good afternoon, everyone. My name's Rob Moore.
My name's Matt Davies, and we're principal consultants at Redify.
Today we're going to be talking to you about something that we call microtesting. Now, the easiest way for us, or probably the simplest way for us to describe what it is the tagline here. So we're trying to be a bit smarter about how we test by embracing simplicity and continuous improvement. At least we thought that was the easiest way, but earlier I was talking to Andrew Best there, and he described it to me as pragmatic testing. So let's run with that.
Yeah, cool.
So a fair number of you are probably wondering, what's microtesting? Why did you call it that? Because we made it up. It's a completely made up term. We came up with it last year when we put this talk forward for a YOW conference. At that time, and frankly, even now, if you look at the agenda for NDC, there's a lot of talks about microservices. We kind of just wanted to jump on the bandwagon.
Yeah.
But a little bit more seriously, we've been finding with the sort of practices and techniques, I guess, that we've been using, and the approaches we've been using for testing over the last couple of years, that we've been writing less tests and spending less time testing, but actually getting more out of it and getting the same or better confidence. So it's kind of a strangely appropriate title anyway.
Yeah. And as consultants, we get to see a whole heap of different testing strategies. We get to see just about everything under the sun. We get a lot of opportunity to do research into this stuff ourselves, and we get to play around and try to write some of this stuff ourselves. And what we find just in looking at a lot of what's out there is just like complete garbage.
There's some awful testing code
and
out there.
we've written a lot of it.
We've written most of it, probably.
We can't make any excuses. So what we want to try and do as a part of this talk is try and share some of the lessons learned, try and share some practical advice and tips for how to do some of this stuff in a better way.
Yeah, and I guess leveraging some of the experiences we've had over the last couple of years and some of our successes and failures and stuff like that. So we've decided to break this talk up into a number of chapters. First chapter is about confidence, and you'll understand why as we go through.
Yeah, this chapter is really easy. So we're basically going to tell you all about why the testing pyramid is the answer to all of our questions. It's going to
hail the testing pyramid.
This is the testing pyramid. You might remember this from, I don't know, your days in university or your early days learning about this stuff as a developer. You've got a relatively high ratio of unit tests down the bottom, a smaller ratio of integration or service level tests above that, and an even smaller level of UI level or user-facing tests. And to be honest, we completely fundamentally disagree with this for a whole heap of reasons.
This makes us sad.
It makes us really sad, so we've got a sad face there. The testing pyramid mandates that you do everything according to a very rigid structure. It says that you're going to have this many of this type of test, this many of this other type of test, and it forces you to, I guess, try and figure out what these names for things even mean. I mean, hands up if you've ever had an argument with someone over whether or not a test is a unit test or an integration test, right?
That time that you spent is a waste. You could have been spending that time delivering value rather than arguing if something's a unit or an integration test. Who cares?
Yeah, exactly.
As long as it delivers value.
Yeah. And the other thing to consider is that this testing pyramid doesn't take into account the concept of what we call speed versus confidence.
Absolutely. So when we talk about speed versus confidence, what we mean is speed is you've got some sort of test suite. How long does it take from starting the test suite to when you find out, according to that suite of tests, whether or not there are any bugs in your software? That's the speed. And then confidence is once you've run that suite of tests, how confident are you that there's a bug in your code? Or put another way, how confident are you to click a button to push your code to production?
How confident are you to let your product owner push a button to go to production?
Absolutely. So if we look at trying to graph, I guess, speed versus confidence, if we look at, say, manual testing or automated UI testing, these execute the full production stack of the system similar to what an end user would do. So you get a lot of confidence from running these types of tests, but relatively speaking, they're very, very slow. If you compare that to your traditional unit tests, they typically run in process, in memory. They take a few milliseconds to run, but the amount of confidence that those tests give you is relatively very small because you're only testing a tiny part of your code, and quite often you're mocking out production implementation details. Now, if you take one of these unit tests, you add in some real database calls, you've now got out-of-process communication. It's an order of magnitude slower. But there's a whole class of errors that you will now pick up in your tests around things like, does the SQL work? Are your database migrations correct? Does your ORM correctly hydrate your entities, et cetera, et cetera? Now, if we try to graph these, what we're kind of finding out here is there seems to be an inversely proportional relationship between speed and confidence. Now, if we come back to the testing pyramid, there's nothing in here about speed or confidence. It's just a very rigid structure. And on that point of a rigid structure, the reason why that's such a problem is pretty evident when we obviously have a lot of experience going between different clients. We see lots of different circumstances. One of the things that we notice is between different teams or between different companies, there's a lot of scenarios where your approach to testing should be very different. So say you've got the Juno rocket by NASA. Now, if someone's kind of like messed up some code in that, and then the rocket explodes, how many years have you wasted, right? NASA aren't going to care if they have to pump a few more $1 million in to get some really good test coverage on that.
Yeah.
And it absolutely makes sense to do that in that scenario.
On the other hand, if you've got, say, like an admin system that's used by like 2 people who sit next to you, it might be enough to just have one UI test that just sits over the whole thing, and you just kind of say that's enough. If anything goes wrong, these people are just kind of there and available, and it's actually not much effort to sort that out.
Or shock horror, no UI tests at all. And that's actually a really good example, the admin system, of an example where even within one system, different features in that system will have different, I guess, confidence levels that make sense and different, I guess, amounts of testing that make sense. So admin system over here, we don't need much tests. Over here, you've got a bank with a mortgage application form. If you mess that up and users can't actually fill that out, you're potentially losing millions of dollars. You're going to put a bit more rigor into the mortgage application form. Now, Jimmy Bogart has a really good talk that he did in NDC Oslo 2013 called Holistic Testing. Highly encourage you to watch it. He introduces this as his testing pyramid in that talk. Now, I really like this. So what he says is, have a high proportion of fast tests, a slightly slower proportion of slow tests, and even smaller proportion of slow as hell tests. This is good. It takes us a step in the right direction because at least now we're talking about our speed of feedback, which is really important. But it still doesn't go far enough in our opinion because it's still very rigid and it doesn't talk about confidence. So you might be wondering, what's the testing pyramid that we use?
What do we do? Yeah.
Oh, there we go. Oh, Matt, where's the testing pyramid?
It's supposed to be on this slide.
Is it under here? Damien, where's our testing pyramid? Do you have it? No?
Is it?
Oh, hang on. I think it's in my bag.
Somewhere?
Hang on. So make it burn, basically.
Yeah. So as we kind of said, we completely disagree with the idea of having a testing pyramid. It locks you into a pretty rigid structure. So let's just get rid of it and let's come up with something individualized based on what we need to do.
So then you might be wondering, okay, we've thrown out the testing pyramid. How are we going to decide what kind of test to write?
People are going to be lost. They're going to be walking around in a daze of confusion.
Confused, yeah, absolutely. But I guess what it comes back down to for us is what's the most important thing to think about if you're trying to decide, cool, this is a feature I'm writing. What kind of test should I write? How should I test this? Should I even test it at all, etc.?
Cool. So to start to make a decision around some of these things, we've got a really good quote here from Jimmy, who from the same talk that Rob mentioned. And what he's basically saying here is that the goal of testing isn't actually to test. It's to come up with a level of confidence that our app's going to work. It's just a means to an end. You can have all sorts of different levels of code coverage, but you could have 100%, and it doesn't necessarily mean that your app's going to be successful. It's completely unrelated. It's confidence that's important rather than a level of code coverage.
So let's really drive that home. The goal of testing is not to test. So if you're kind of finding yourself writing a feature and then without thinking, you just start writing a test, because that's what we do. We just write tests. Does that test give you any value? You should stop and think about that. In our opinion, the goal of testing should be to get enough confidence, enough being a really important word in that sentence, as quickly as possible, because tight feedback loops are really good. They speed up our teams. We know that developer velocity is typically something most companies care a lot about. So that leads us on to talking about speed of release. I would make the assertion that you're probably not going to release your software until you have some sort of minimum confidence level in that software. If you think that the software is buggy in some way, you're probably not going to deploy it to production. Doesn't make any sense.
You don't want all your users to leave you, right?
Exactly. So we've kind of come up with this completely arbitrary graph, looking at the amount of automated test coverage that you have versus speed of release. Now, I guess this is just based on what we've seen in a number of companies that we've been to. On one hand, if you don't have any automated test coverage at all, you've probably got a team that has a fear of refactoring, and obviously that means you're probably going to get technical debt build up, and that's going to slow you down. You're probably relying on a lot of manual regression testing, very slow, doesn't actually pick up all the bugs, and there's probably going to be a lot of regression, so you're probably going to be spending a lot of time fixing bugs. All of these things slow us down. They slow down our speed of release. But on the other end of the scale, what we often see is people going the opposite and testing everything to the nth degree and putting these huge UI testing test suites and frameworks that are really brittle and give us low confidence and have things like intermittently failing tests, or they will spend a lot of time running tests. We've been into companies that have like 24-hour test runs. That's a crazy, crazy feedback loop to get feedback.
You start to get pretty disillusioned with whether or not they're actually giving you any value at all, right?
Exactly. And because they're spending a lot of time testing to the nth degree for every single feature, they're spending a lot of time writing tests. Sometimes like orders of magnitude more time writing tests than actually writing the feature. Now, as we said, in some circumstances, that's appropriate. Think about the Juno rocket. But to be honest, these days, a lot of companies really care about speed of release, and there's a whole heap of added benefits that you get if you release software quickly. So this is something that's probably pretty important to think about.
So the main things that we want to put as takeaways for this section is that we really want to consider speed and confidence when we're writing our tests. We really think that the testing pyramid is too rigid for our purposes, and we want to come up with something custom based on each application that we're doing. And confidence is really the most important thing to think about when we're trying to come up with our testing strategy.
Absolutely.
So we kind of talked a bit about what we don't like. Now, how do we figure out what we do? So we've got a bit of a quote here, which we just try and apply to everything we do, which is challenge yourself to start simple and then inspect and adapt. And the really important word here is challenge, because as I'm sure you've come across before, it's really easy to come up with something super simple. It's amazing, it's super clean, and then you go, I don't know, 6 months down the track and it's become this complex monster. So,
or the other thing, of course, is quite often you tell someone to start simple and then they start by shaving a yak and have this crazy thing. So by really challenging yourself, you're more likely to actually start with something simple.
Yeah. So if we go on, what we've got is, I guess, 3 rules that we try and apply when we're trying to come up with a testing strategy. The first of those rules is to try and challenge ourselves to set a minimum confidence level that's absolutely as low as possible. And there's a few key things there. Setting that confidence level minimum as low as possible is really important. And if you think about going to your typical product owner and saying to them, hey, we want to accept a level of confidence that's not 100%. We want to accept the fact there might be some bugs. You're probably, your first reaction is going to be that they're going to go crazy. They're not going to like you much at all.
Despite the fact, of course, that there's always going to be bugs, but that aside.
Of course, yeah. But they want to think that you're doing something that's 100% confidence, right? Something else that's really important to them, and this might require a bit of recoaching, a bit of training, is that the speed of release on a lower minimum level of confidence can be a lot higher. So it's just something to balance up when you're trying to move quickly.
That inversely proportional relationship. Another thing to keep in mind with this is if your team's using techniques like continuous delivery, if there is a bug, that team can fix it pretty quickly. So that kind of offsets that risk in most circumstances.
Yeah. The second thing that we're trying to think about is how do we come up with a testing strategy that meets that minimum level of confidence as quickly as we can? So this is where we start to apply a lot of software development practices to tests, and that's something that we can quite often forget. We can quite often end up with tests that aren't refactored and don't have a lot of thought put into them, but it's something that's really, really important. And the last thing is making sure that we're actually adapting that over time. We've been to a lot of places where it's easy to fall into the trap of ending up testing your app the same way a year down the track. And
10 years down the track.
There's so many lessons you can learn based on what happens. So it's just really important to think about how we adapt this over time. So we kind of started this chapter with the business, right? So where does the business come into this? That setting of a minimum confidence level as low as possible, that's actually a business decision. And a lot of people who look at testing think that automated testing is purely a software development thing. It's not. figuring out what's that level of confidence that users are going to tolerate, what's the risk that we're going to tolerate, that's very much something that your product owner should typically try and decide.
What's your communication mechanism with your end users? You know, is it really tight and you can kind of deal with the fact that, oh, there's a bit of a bug, but it's okay, we've got it covered, we'll have it fixed in an hour. You know, this changes the dynamic of what that minimum confidence level is.
Yeah, that creating a testing strategy that meets that minimum level of confidence as quickly as possible, that's very much a technical thing. That's where we can shine, right? That's where we can come up with something that really hits that confidence as quickly as possible by really applying everything we know how to do. And the last point there about adjusting the testing strategy over time, that should very much be something that everyone is involved in. That should be something that we're really taking into account when we do our retrospectives, when we're trying to continuously improve, is how do we apply like different metrics? How do we figure out if we're actually improving this strategy? Some things you can look at is like how many bugs are getting into production, like how confident are you when you're deploying?
How long does it take from someone having an idea to that idea being in production?
Yeah, there's all sorts of things you can really look at and track and apply over time to see if you're getting better at this stuff. So that's really important, I think.
Definitely. So let's say you apply this technique. You start off with a really simple testing strategy. Every time we build a feature, let's just do this type of test or something like that. That's the fastest test we can write for our minimum confidence level. So you might wonder, is that an oversimplification? That doesn't sound like it's going to work in the real world. Well, I'd say yes or no. Sometimes we may well start with a testing strategy that simple, but the whole point of what we're talking about is you need to inspect and adapt over time. The testing strategy is not going to stay that simple. Over time, you're going to figure out, oh, we need to cover this type of thing because otherwise this sort of error seems to happen, and then we're going to add this sort of thing here. The good thing about that is we're not applying a rigid structure and saying you have to test the same way everywhere. We're being smarter about how we test.
Yeah, and this is how you prevent it getting too complex as well. Sure, it might start simple. You also don't want it to go too far the other way. So.
Absolutely. So now that we know what our testing strategy is going to be, what we can do is we can hire all of the consultants. We can get them to write like a 100-page report. We're going to put them in a room with our enterprise architects. They're going to start whiteboarding a synergistic testing strategy. And then what we're going to do, no, don't do that. Okay?
What we actually want to do is we want to empower people, right? We want to empower people to be able to make these changes. We want to try and make this testing strategy not necessarily even per project, but sometimes per feature, sometimes different depending on the different area of the system. And we want to make sure that we're adapting it over time. That's the key stuff out of this.
Please change your testing strategy over time based on how it goes. Don't just keep it static.
So main points out of this is that try and make that minimum confidence level a business decision. Try and educate people on how to make that decision. Try and empower them and give them the right tools to make it effectively. And really focus on how you can help, I guess, meet that as quickly as possible in a technical manner. And the last thing, which I know we've said a few times, but really make sure that you're continually improving it.
Awesome. Okay, so we're going to take a bit of a change of tact now. We're going to look at a few different types of testing. The first one is the funny type of testing. And I say funny because it's a weird word, subcutaneous. It takes a while to figure out how to pronounce that, but I can do it fairly fluently now, which is good. It's a weird word. It's a medical word. It basically means under the skin. And that'll make sense in a sec when Matt explains what a subcutaneous test is.
So basically, a subcutaneous test is testing not at the UI level, but just underneath it. So if you've worked with MVC before, for example, that can be testing at the MVC controller level. It's whatever level is the first entry point into your code base. You'll use real repositories, real data access, real services behind that, but make sure to mock out anything that's external to your system, which will typically just kind of add fragility and not give you a lot of confidence by testing. And there's better ways of testing that. If
your system owns the database and performs migrations on it, it owns the database. That's part of your system. Don't mock the database out. So what we get out of this is a few different things. We get a huge amount of confidence out of this type of test because it's using the same code paths that you're actually using in production, and you're taking away some of that problem that we have when we're constantly mocking out different features that exist. You can refactor really easily. I mean, hands up if you've ever broken like half of your test suite by refactoring something, right? Like, we have all the time. And the problem with that is when you do that, and you then have to change all of your unit tests because they now no longer work with your refactoring, you're not getting any confidence from those tests. They haven't assured you that you haven't broken the app because you've just changed them.
Yeah.
Yeah, you need to get a voice back, dude. But it's also not refactoring at that point. Refactoring is not changing tests. Refactoring is just changing implementation details.
Yeah, if we wanted our tests to break, it should be if we've changed some kind of business rule, right? That's where they add value. That's where they're helping us. So what we're trying to aim to do here is just reduce some of the mocking. It doesn't work in all situations, which we'll cover in a little bit, but it certainly helps a lot in certain ones. Another thing that you can do here, which is kind of cool, is combine this with testing behavior and acceptance criteria about the features you're trying to introduce. And that lets you do really powerful things like add a subcutaneous test for a certain type of acceptance criteria, which you can then show to a product owner to give them a lot of confidence that you're actually testing the sort of business rules that they want to see in the system. And that helps them make the decision that we kind of alluded to earlier.
And you can do AT to D and use that test to drive the implementation of the feature. So you can still do red-green refactor with this type of testing. So they sound pretty good, right? Subcutaneous tests, they're pretty cool. And certainly, we've got to admit, we've had a lot of success in using them.
Yep.
So they're the silver bullet we've all been looking for, right? No, they're not. Okay, there's no such thing in software as a silver bullet, yeah? Context is everything, okay? So in particular, for instance, there are some disadvantages and some maybe difficulties of using subcutaneous tests that you'll come across. One of them is if you've got really complex code, maybe some sort of complex algorithm or something like that, it's really hard to drive that from that high level and get a reasonable amount of coverage if that's something that makes sense in this instance. You get a combinatorial explosion. But this is okay for two reasons. Firstly, sometimes you don't need that level of coverage of that code. Maybe a couple of happy paths is all you need, in which case subcutaneous tests are great. Or if you do need that level of coverage, then what you do is, great, we do maybe one subcutaneous test if we even need to, and then we decide for that code, we're going to dive down, do a lower level test, which is much easier and doesn't have the combinatorial explosion problem. That's the whole point of what we're talking about. We shouldn't use the same type of testing everywhere blindly. We should make smart decisions. It can also be hard to know why something's broken. So the whole thing about subcutaneous tests is you're testing a fairly large proportion of your code with each test, right? So if something goes wrong, it can be sometimes confusing to try to figure out where it actually went wrong. Now, there are some techniques that we can use to make that easier, and we're going to go through a few of them towards the end of the talk. Quite often what you will have as well is, given you're testing the full stack of code, that includes a fair number of cross-cutting concerns. So if you go and break something in a cross-cutting concern, what you can find is that then that breaks, say, like 40 subcutaneous tests or something like that. That can be quite confusing and disorienting to some people. Personally, I don't mind, but I've come up with a fairly, what's the right word?
A fairly consistent approach.
Thank you. Where I basically look at one of the broken tests, ignore all of the others, figure out what's wrong with that test. Why did it break? Fix the problem, rerun the whole test suite. A bunch of them will now pass, rinse and repeat until there's no more red tests. It's a fairly easy approach. And then the last one is saying that because we're testing a reasonable amount of code, the tests themselves are more complex. And they're more complex in three ways. If you think about arrange, act, assert, the arrangement of your tests and figuring out all the test data to get it in the right format, probably a bit more complex. What you're actually calling, definitely more complex. And then coincidentally, what you're asserting, probably also more complex. Now, again, we have some techniques we can use to deal with this. But essentially, all it boils down to is using the same practices that we use for our production code for our tests. We should refactor tests, and we should use patterns and practices in our tests that we know lead to better tests. Again, we're going to cover a few strategies towards the end of the talk that will help with some of this.
So main things from this section is that cool, that's an interesting new type of test. It's definitely worth checking it out. It's really good for balancing that speed and confidence because it hits a fairly good balance in a lot of situations between both. We find that mocking implementation details leads to a lot of pain, so try and avoid it where you can. There are situations where you need to do it though.
Absolutely.
So we wanted to talk a little bit about unit tests. So unit tests is a bit of an overloaded term, as we kind of alluded to earlier. What we've decided to call them, just for the sake of this presentation, is an implementation test. So by this, we're referring to an in-memory test in process. They're usually extremely quick. You can run like 10,000 of them fairly quickly, but they give you that lower amount of confidence because you're generally only testing an incredibly small part of a system, and you don't necessarily know how well that works in with everything else. complex. They inhibit your ability to painlessly refactor, that break all your test situation, but they're really, really useful in the right situation. So if you've got a particularly complex piece of code that you need to that you really need to figure out. If you're doing T2D, for example, a lot of feedback we heard, especially in the early era of T2D, was it gives us a lot of ability to more easily design our code in our heads before we write it. So that's kind of cool. What you need to consider if you're following that kind of approach is actually, once you've come up with your test, is it still delivering you the sort of value you want over time? If it breaks very, very often, if it breaks every few days, you really need to look at it and go, should we actually keep this test or should we delete it? And a lot of people are terrified of deleting tests, right? It's just something that's not that familiar to us.
Absolutely. I mean, and then the other decision point is maybe it is worth keeping it and dealing with that pain, because the fact that you needed that test to drive that complex code in the first place might mean it's helpful later on as you're supporting your code and changing it. There's no right or wrong answer here. It has to be contextual.
Cool. So next, I want to talk a little bit about UI tests, UI automation. This is something that we find is a struggle in a lot of places. This is something that causes people a lot of pain. So automated UI tests, just to be clear, I guess, are great in the right situation. They give you a huge amount of confidence when they work. So if you've got a particular test that's clicking through a system as a user, and it successfully clicks through that system and gives you back the right output, you've got a fair amount of confidence that someone coming along as a real user and clicking through that system is going to get the same result. So that's great. The problem with them is that they're typically extremely slow and they're typically extremely fragile. So what we want to do here is think about where we can apply them that gives us a lot of value. And oftentimes that's in particularly complex UIs. If we're talking about a really complex client-side application maybe, where there's a lot going on, these become really, really useful. And there's a few other ways to get that same level of value. So it's just important to think about the fact that there's a trade-off here.
Or think about that mortgage application form scenario. Those
Sure,
high-value scenarios where you need to know that that thing works according to the end users, right? In that case, you make the trade-off. You trade off some slow and fragile tests in return for the high confidence you need in those parts of the system.
Yeah.
But again, that doesn't mean you apply that for every single feature across the whole system.
Might just be that one form.
Unless it makes sense. Yeah.
So just be smart about how you do these things. What we can typically find ourselves falling into a trap of a lot is over UI testing and ending up spending a lot of time trying to sort out issues rather than delivering value.
Now, we're not covering it in this talk, but one thing to note about automated UI testing is that, just like what we talked about with subcutaneous testing a few slides back, using our patterns like refactoring and a lot of different software patterns and all these sorts of things, page objects, etc., are really important for automated UI tests. So you can limit the fragility of them, and then you're just dealing with weird things like when you upgrade Firefox, Selenium WebDriver doesn't work anymore and stuff like that.
Yeah.
So the next thing we're going to talk about is just walking through a potential scenario where we might walk into a client and how we might decide on a testing strategy, just to give you a bit of context for how this might go. So context is really important here, yeah? So we've already talked about different scenarios where different testing strategies make sense. So to try to limit this is a typical scenario we might see. Some sort of small to medium line of business application across heaps of different industries, doesn't really matter generally, with a relatively small proportion of sort of complex algorithmic sort of code, not real time or life or death or anything like that, and a team using continuous delivery so they can fix things pretty quickly, right? In that sort of context, what we might end up with initially is something like this. We might say, cool, when we do a feature, we'll do a happy path and maybe some important error paths for subcutaneous tests. If we've got any API calls, we'll spin up an in-memory full-stack HTTP server. It's kind of similar in a lot of ways to subcutaneous tests, because obviously there's no UI, right? And for any of those calls. And then we'll use a small but judicious use, depending on what makes sense in different parts of the of things like convention tests, route tests, integration tests, implementation tests, any end-to-end tests if that makes sense if we're talking across multiple systems, and maybe a few UI tests here and there, right?
Convention tests in particular, if you haven't looked into before, are
Yeah.
really, really awesome. It's the type of test where you'll write them once and the test will automatically adapt to code that you add after that. And happy to chat about that more if you want to come see us after.
It'll use reflection typically to look at your code and make sure you're following certain patterns, basically. Very powerful type of test. Test-stack.conventional, right? Yeah, cool. Okay, so what we're going to do now is look through some code. So the code we're going to show is kind of C#y, and we've got it on, there's a link at the end so you can go and see the code and get the slide deck and stuff like that.
This sort of stuff is possible in just about every language though. So again, like something we can chat more to you about if you've got kind of questions and use something else.
We've used these techniques, for instance, in JavaScript before pretty successfully. So this part of the talk is basically going to be looking at, okay, we've got subcutaneous testing. You've said they're really good. You've said there's some disadvantages and some difficulties. What techniques do you use to try to overcome that? So this is basically our learnings. Should we swap?
Yeah, cool.
Yep. All right. Nice. So the first thing that we're going to demonstrate is an implementation test that you might typically see versus what a subcutaneous test version of it might look like. So we're just using Visual Studio Code here. So here's an example. Say we've got a student controller. The student controller takes a repository, and in this case, we're mocking it out. This is in substitute syntax. We've got a test here that says that the index action should show students. So what we're doing is we're setting up some expected students here, and then we're saying that the getAll method on the student repository should return those expected students, and then we make our assertion. We say, cool, when we call the index action on the controller, it should render the default view, and it should have a model where the view model count should be the same as the expected students, and then the names should be what we expected them to be. Pretty simple, standard sort of stuff, right? You might then combine that with a test that's testing just the student repository. In this example, we're saying that there's a real database being spun up in the background as well. And then what we say here is that the getAll method returns students in the database ordered by name. So we set up some expected students, we loop through them and basically save them into the database. We call that getAll method, and then we check that what was returned matches what we expected ordered by name. So this is something that you might typically do. We've certainly done this in the past. Now, if we were to convert this directly to a subcutaneous test without applying any of the other patterns that we normally use, so there's going to be a lot of things in here that make me really uncomfortable, but we'll do that just to show you, then it might look something like this. So in our test setup, when we new up the controller, we're using a real student repository with a real database connection. Okay, so we're not mocking any of that stuff out. It's just full end-to-end. What we're going to do is add the expected students into the database, like we did in that database test. We're going to call that index method, check it renders the default view, and then pull out a reference to the view model that was passed to that view, and then check that that view model had all of its names in the right order. So this is essentially a combination of those two tests we wrote before. So now we only have to write one test, which is nice. It tests a whole bunch of things, and you'll note that that getAll method is nowhere in here at all. That implementation detail that there's a getAll method has disappeared.
We could replace that with an API. We could replace that with whatever we want. It'd still just work.
Yep. So it's pretty cool. Now, there are a few issues still with that, but bear with us.
Cool. So we want to try and look at some, I guess, patterns that we can apply to this stuff in order to start cleaning this up even more. One of the things that I'm sure you've come across before is behavior-driven tests. Behavior-driven tests in combination with subcutaneous tests can be really powerful because they give you a huge amount of confidence that the behavior that you're describing in your test matches what it is that you're actually testing. And they give you a huge amount of focus, I guess, as well, in that you know fairly easily what it is that you want to test. And you've got a fairly easy path to follow in that if you add a certain type of rule to the system, you go, okay, cool, we make a decision at this point as to whether or not that makes sense as a test.
It gives you focus because you're basically got a test that's talking about behavior and you're focusing on trying to implement the behavior, as opposed to where you're writing implementation tests where you're focusing on trying to write the implementation. It's a very different state of mind.
Cool. And I guess the last thing is that we find writing them in this fashion, it makes them a lot easier to read and a lot easier to write as well. So worth having a look at.
So let's have a look at a demo. So if we convert this subcutaneous test that we just showed you to use, in this case, something called test-stack.bdify, there's a whole heap of other libraries, this is just the one we typically use, then it's starting to look a little bit different. Now, we're also using a pattern here called class per scenario. So every test is a class as opposed to having multiple tests in one class. We actually find this is quite nice because what you'll typically find is we use something else called organized by feature for the MVC app. So you'll have like a features folder in the test thing, and then for each feature, in this case maybe it's students or something like that, then in that folder there'll be like, in this case it's the view existing student scenario, and then you might have successful registration of a student scenario, and like you'll just have a list of them there. It actually is quite nice from that perspective. But anyway, again, we're newing up the student controller with the real dependency and a real database. Then we've got these different methods now. So given existing students, and then in here we're just saving those students to the database like we did before. When the user views the students, so we're just calling that index method, then the user should see students ordered by name, and we're putting that other logic we had before. Now, the nice thing about this, and if you remember, one of the disadvantages I said was it's hard to know where something's wrong when the tests break. In this instance, especially with a library like bdedify, it kind of says, hey, this test broke with this exception in given existing students. At that point, you've really constrained where you need to look. It's something to do with the data that you've put in the database, right? So that's quite useful.
Another thing that we can look at doing, so you would have seen in some of those examples we're newing up a lot of stuff, right? That's an implementation detail. And a way that we can start to deal with some of those is by driving our tests using the same dependency injection container that we're using in production, if we're using a dependency injection container. That lets us avoid those newing up implementation details that we don't really need in a test. It makes sure that we're using the same code paths that we're actually using in production. We kind of covered before that we're trying to avoid mocks where we can, but there are situations where you need to use them, and this is a really easy way to substitute those in if you have to.
Yeah, and you don't have to worry about which component it is uses that mock. You just say, DI container, here's the mock. Go and inject it wherever you need to. It's quite cool. Now, you'll see that this in particular really starts to clean up our code. So if we take this same test, and we look at what it might look like if you introduce a DI container, there's a whole bunch of stuff we've now changed. One of them is we've now actually introduced a base class called subcutaneous MVC scenario, and we're passing in the type of controller. The reason why we do that is because now we don't need to new up the controller. You can see here that setup method, if we go back to the bdedify example, here, all of that's gone. So this is actually, in reality, an implementation detail, the fact that the controller needs a student repository. We shouldn't care about that. If you then refactor your code base to add the query pattern or whatever it is that you want to add, our test shouldn't break. So the container allows us to do that. So by passing through the type, the code inside of the base class will just resolve that controller from your production DI container and any dependencies it has and any mocks that you've registered. So it's pretty cool. The rest of it's pretty similar. We set up the database with students. We've now got a nice helper method here to execute the controller action based on a lambda, simply so that we don't need to have a private field for the action result, and we can just use the action result here. Just a nice little optimization. But the rest of it's essentially exactly the same. But this is starting to look really nice now. There's basically no implementation details, which is pretty cool. Oh, that was cool. Yep.
So the next thing that I guess we can look at is how we can deal with mocks. So as we kind of said before, in this type of test, it's really important to mock external dependencies. We really don't necessarily want to be calling those where we can avoid it. But there's an approach we can kind of take in order to help make this a little bit less painful where we do have to do it. So something we've been trying to do is hand-rolling mocks instead of using a mocking library to substitute them in, which is pretty crazy, but it does two things. A, it makes mocking a little bit more painful. So if you've got someone new to the project, they're a little bit less likely to do it. But the second thing is that you can codify certain behavior within your mocks that make your tests a lot more readable. So if you've got code that you have to use in your tests when you're doing a particular mock, setting it up in some certain way, you can provide a method that's just a part of that mock that does that for you, and then your tests don't need to duplicate that logic each time they do it. So we'll show you what that looks like.
Cool. Okay, so we're going to move on from this student controller scenario for the rest of these. So here's an example of an interface you may have in your production system. iDateTime provider. It's pretty standard sort of thing, returns datetime offset from a now method. And this might be what your production implementation looks like. We're just returning datetime offset.utc now. Pretty easy. This is what a simple hand-rolled mock might look like. When we construct the mock we grab a static value of now, and then we just always return that. That's actually quite useful because it means that when you're using this thing in your production code that you're testing, then afterwards when you're doing assertions, you can just resolve this out of the DI container, call now, and get the same value that was used, so it's easy to do assertions. But we can be way better than this. We can start doing the codification of behavior that Matt was talking about. So here's another example of what this could be. Now, in this example here, we've got a couple of new constructors, kind of interesting. We've got one that takes a date time offset so that you can actually explicitly set the time. That can be quite useful in certain scenarios. We've also got a version with a string so that you can do data-driven tests with attributes because they have to have static compile time constants, so they have to be strings. But we can go even better than this. We can do things like set now. So now you basically created a time machine, yeah? So you can resolve your static date time provider from your test, call .setNow and change the time. So you could do something like register a user and then set now to a different time and then perform some other action and check the last modified date is different from the created date. That's really easy to do in that sort of instance. Even better, move time forward by a time span. The code to do this, if you didn't have this nice codified method, would look something like this. Provide, so to provide something to your DI container, a new static datetime provider, and then resolve the current datetime provider, get the now value, and add a time span to it. That's just like you start reading that and your brain melts. You don't know what's going on. It's not clear code. It's not self-documenting. However, if instead you just had, cool, resolve the static datetime provider, call .move time forward by timespan.hours1. Awesome. It's pretty obvious. We just move time forward 1 hour. Much more readable. Right? This is where our refactoring comes in. Then you can get even more crazy if you really want to, and you can do stuff like this. You can say, cool, let's create a using block, and then inside that using block, let's temporarily change time by 4 hours. And then after the using block, it'll be back what it was again. You can do all kinds of cool stuff like that. And this is just one example using time, right? But you can do this with pretty much anything that you're mocking out, which is typically in a subcutaneous test at least, going to be external dependencies, like time or API calls.
Cool. So another couple of patterns that you might have come across before. So the object mother pattern and the test data builder pattern. We've seen these a fair bit, and something we've found is that these two actually work really, really well together. They give you a huge amount of consistency and clarity in how you set up data within your tests. If you think about a typical test, there's usually a fair bit at the top of that test that's trying to figure out, okay, how do we set up this test in the right state so that everything just works.
Especially in a subcutaneous test where, as we said before,
there's a lot going on.
Your arrange, act, and assert are all going to be more complex. So you're quite often going to be setting up reasonably complex chains of objects.
Yeah, so what we want to try and do here is figure out a way that we can start to remove a lot of that duplication and complexity and make it really clear to someone who's reading the test exactly what we're doing with our data setup. And this is just one way to do that.
Okay. So for this one, we're going to take a slightly different tact. We're not actually going to show you a subcutaneous test for this example. We're just going to show implementation tests. That's fine. It still demonstrates the value of these methods. So in this case, we've got given demographic with state and age range when checking if, when checking if the demographic applies to a member, then return true only if the member conforms to all parameters. It's a bit of a weird long one. But anyway, that aside. Essentially, we've got some sort of domain where you've got a demographic. It's got some properties in it, like an age range and stuff like that. And then you've got members who, they have like an address and the name and an age and all that sort of stuff. And the demographic will check whether or not you can check whether or not a member applies to a demographic. This is actually based on code that we wrote for a client. So this is a real thing. Now, this is where the patterns show up. So for the member, we're going to say object mother.members.Fred, right? Fred's just a member. We don't care about this particular member. We just need Fred. We just need Joe. We need whatever, right? It's just a member. But what we can then do is customize it and say, cool, we want a member in the state of state, the one that was passed through in the data-driven test. And we want a member that has the age of the age that was passed through. This is the combination. So this bit here is the object mother. We just get a pre-built object, or in this case, actually a pre-built test data builder. And then we customize it in this test. Trying to do that with just object mother is gross. Now demographic, we can say, cool, we want object mother.demographics.members in WA. The cool thing about that is you can probably reuse that in a bunch of places, right? It's probably something that's quite standard to all of your tests. You've just refactored some of your, if you were just using test data builder code, so that you're not reusing the same dot in state WA everywhere. And then in this case, where they say, cool, minimum age of 18, maximum age of 19. And the demographic contains that member when the state is WA and the age is either 18 or 19. So this stuff then takes on a mind of its own when you start looking at building lists of entities. So in this case, we say, cool, we want a WA member. And we want a list of 3 products. The first one has a campaign for all members, so that one will apply to the member. The second one has a campaign for ACT. That one won't apply because they're in WA. And the third one has a campaign in the state the member's in this case WA. So the first one and the last one should apply. And in this case, we're testing a query. So we're saying given products with a variety of state rules, when querying products for the member, then only return the products that apply to the member. So when we execute that query, we should only get back the first product and the last product. Now, if you think about what this might look like if you were using constructors, right? In particular, this product list, you're going to be like newing up 3 products, and for each product, you're going to pass in a bunch of stuff like a name and other things, and then you're also going to have to pass in a campaign, which is probably on a domain method because you probably wouldn't pass that into the constructor. So like that code's just going to get huge.
And a lot of that stuff doesn't matter. It doesn't help you in understanding this test and what kind of data is actually essential for it to run.
There's a lot of noise. Like for instance, the product name, who cares? This test is concerned with states. The nice thing about this pattern is you only put the data there that matters for this test. You've removed a bunch of noise, which makes the test a lot easier to read. It's awesome.
Cool. So the last pattern that we want to talk about that can help you out in some of this stuff is approval tests. So approval tests come up all the time in work that we do. It's basically the idea that you use the human brain as an approval mechanism instead of writing a whole heap of different assertions. And the way that that works is you'll run some code, you'll get the output of that. Sometimes it could be like a complex piece of JSON. You can do this with images. You can do it with all sorts of things. The first time that you come up with the test, you'll save that result to a file somewhere that just gets committed with the code base. And then in subsequent runs of the test, if that output changes, the developer who's changed it gets a diff window with whatever happened. So you can pick up little differences in that output that have changed unexpectedly, or you can mark stuff as okay if it changed and you did expect it, which in certain scenarios, if you're trying to test like really complex objects, you can spend a long time writing assertions and keeping those up to date over time, whereas this just lets you do it automatically using whoever's making the change. It's pretty cool.
And like we said, in the subcutaneous test scenario, a range act assert are all probably a little bit more complex. So this is a technique you can use to try to make that assertion bit a lot simpler. Let's show you an example of that, because it really speaks for itself when you see it.
Yeah.
If you guys has anyone heard of approval tests before, by the way? So maybe
cool,
like
nice.
A third of you. Yeah, so this stuff blows people's minds when we show it. Okay.
Especially when you show images, but we don't want to do that for this demo.
Yeah. Okay, so we've got just, let's say you're an ISP, yeah? And you've got a shopping cart for users, right? And you want to test the scenario where the user comes to your shopping cart, they say, cool, I want MBN, and I want VoIP, and I want the international call option. Then what would happen, in this case, we're saying, cool, it's an NBN VoIP, and international calls checkout scenario. And it's a subcutaneous MVC test for the checkout controller. And so given the user has started a session, so we're just going to save object_mother.sessions.default. And given the user has added NBN, VoIP, and international call bonus option, so add to cart, products.mbn, VoIP, international call bonus option, and then save it. So we save that to the database. They've done that previously. Given the user has provided their checkout details, so we're just going to build a checkout view model. We're going to populate some random stuff in there, like your name and credit card or whatever it is that it has. When the user checks out the cart, so we call the index action on that controller, we pass through the view model, then register the order. So we'll pull the order out of the database, and then normally you'd probably have a bunch of assertions. You'd check that the view model correctly got mapped to the database entity that got persisted. But then the really interesting part here is, and send request to the provisioning system. So in this example, let's imagine you've got some sort of provisioning system that you send a JSON object to, either a message bus or a HTTP API, it doesn't really matter. In this case, we're going to resolve the mock provisioning system. We're going to call .requests, and that's something that would be this like codified behavior. So basically, that mock provisioning system would probably just stash away requests that come through to it. And in this case, we're going to say there's probably only one. We assume there's only one, so we're just going to get a single. We're just going to get whatever's in there. And then we say request.shouldMatch approved. This is using shouldly. There's also something called approvaltests.net and in a bunch of other languages. What you would then see if you, actually let's look at the approved one. Which one's that one? Is it that one? Yep. Approved, cool. So this is an example of what we've previously said is the correct thing to be in that request, right? So we've got a JSON object, there's some products, there's one with an MBN against an address, and we've got a username and the plan, and we're going to get 50 megabit, that's pretty good.
It's better than the hotel Wi-Fi.
Absolutely. 24-month contract, there's a VoIP one, and actually, there's actually meant to be another one here, but let's say that you just saw the international call plan. You'll see why in a second. And then we've got the customer details, yeah? Now, say you just did some refactoring and you broke your tests and you get a diff window pop up. And what you see is this. Ooh, we broke it. So the great thing about this, right? So let's take a step back for a second. If you were going to try to assert this with like typical assertions, right? Look at that. You would have just like hundreds of like, this should equal this should equal this. It's crazy, right?
Imagine if you were doing an assertion per test.
When this comes up the first time, you get a diff window. You just look at it and make sure that it's right. And you go, accept this file, done. That's literally how fast it is. And then in a scenario like this, we say, what have we done? We've broken it. Oh, the international calls option isn't in there for some reason. Don't know why that is, but I know exactly where to look. And this is where some of the power of this stuff comes in, right? Because if you had a whole heap of assertions, it's like, oh, this product wasn't there or something like that. Like, it's not as clear and immediate as this. This tells you where you need to look. And look down here. Ooh, the work phone. It's got the same value as the home phone. I bet that we've messed up the mapping for that view model or something.
We copy-pasted
accidentally
something.
did .home phone rather than, how many times have you guys done that? I do it all the time. This stuff is really powerful and really cool. So the last demo that we're going to show you is to try to put all of what we just talked about together. So we've got a bit of an example of a scenario that we actually wrote. Yep, we actually wrote for one of our customers. I mean, it's a bit modified, but you get the idea. That pretty much demonstrates all of the patterns we just talked about. Okay, here we go. Successful user registration scenario. This is a subcutaneous MVC test for the user registration controller. Given the valid user registration data has been entered, so we're going to say, cool, we want valid user registration data from our object mother. We're going to execute the index action with that view model. We're going to pull out the user that hopefully is in our database. Then we're going to, then the user should have been redirected to the success page. So we're checking that there. The user should be persisted, so the saved user shouldn't be null. And the user's personal details should be correct. Now, this is using a library called shouldly, which has some really nice syntax that allows you to perform multiple assertions where if one of them's broken or multiple ones are broken, it's still going to run all of them. And if multiple ones are broken, it's going to show you all of the ones that were broken. So this is like a nice way of doing multiple assertions rather than just this should be this should be this, and then the first one that breaks means you don't run the others. This one does. It runs all of them. It's really cool. So we've basically checking here that the view model has been correctly mapped to the database. It's quite powerful. We're doing the same thing here for the postal address. And then here we're checking that the user was actually the bcrypt encrypted version. Now, if any of you were in our talk this morning, you know you shouldn't do this. Don't store passwords in your system, okay? It's bad. Obviously, there's some circumstances where it makes sense. But, and then here we're checking the created and modified date should be set to now. So we're resolving our iDateTime provider and calling now and checking that it's what was in the database. And then we're checking this registration email got sent. So for here, we're getting our mock email sending service. We're pulling out the email that was sent. We're checking that the to address is exactly what we thought it should be. We're checking the subject's correct. And then we can check with an approval test that the body of the email contained the content we expected. We've tested a lot in this test, but hopefully you can agree with me, this is incredibly readable. And if something goes wrong in any of these bits, it's actually pretty quick to figure out what's going on and then to go and resolve it. This, I think, shows some of the real power of this testing strategy. Or technique, I should say. It's not a strategy, is it?
Sure. So I guess some questions to ask to kind of leave you at the end of this talk is, Are you happy with the amount of speed of your tests? Are you happy with the amount of confidence that you're getting out of them? Are you happy with the speed of feedback? How can you go away and try to make the testing that you're doing simpler? You might want to do less of it. You might want to apply a simpler approach. You might want to apply some of the refactoring or some of the patterns we've covered. There's a whole heap of different ways that you can start to simplify what you're doing. And are you trying to think about how you're continuously improving your testing strategy? Are there any takeaways you can make to try and go back and start brainstorming this stuff with the people you work with?
Nice. So that's everything we wanted to say. If you want to get the slides or the code, it's at that URL, but that's about it. Thank you.
Thank you.
So, any questions?
So you were talking about the beginning of the talk. You were saying about trying to make it's a business decision to try to set the confidence level of your testing.
Yep.
And sometimes you can sort of like the product owner should be the person trying to
Absolutely. Yep.
set that. So every once in a while, or most of the times, the product owner isn't really like a technical person. It's more like a domain expert.
Yeah.
Yeah.
And sometimes it has this thing where, what do you mean you have to test something your developer
Absolutely.
should know what you're doing, and other times the other way around. So just what do you mean test everything?
Really happy that you asked that question. We were
it's a good
hoping
question. We got an
someone would.
example. Yeah.
We should repeat it. So for everyone that couldn't hear and for the video, basically the question was, if it's a business decision, what the minimum confidence level is, and you've got a product owner that's not a technical person, they're a little bit kind of confused and they don't think it's their decision, or they don't want to make the decision, or they can't grasp the concept that, you know, hey, we might have a risk of having bugs. Do you want to cover that one?
So we had we applied something to try and sort this problem out in one of our past projects. We basically had a product owner who was saying that type of thing. They're saying, okay, well, I don't really want anything to do with the automated tests that you write. Just kind of leave it. It doesn't kind of help me make any decisions. And what we did is we applied two of those techniques, so beta EFI syntax and subcutaneous tests. And each time we made a change to the system, we just generated basically a report of all the acceptance criteria that were added or removed or changed in the system. And they had that in front of them when they were looking at the button to deploy to production. So they could actually use that to make a really valid business decision as to whether or not people had added kind of too many tests. Hey, I don't care about that one. Whether or not they hadn't added enough, whether or not they'd added the wrong rules, and that really informed that and helped them make the right decision. If they didn't have that kind of thing in front of them, we so often ask product owners, hey, you should be the ones who deploy to production, but without something like that, it's really hard for them to make that decision in a safe way, and they kind of end up a little bit disillusioned with having to do that. So that's just one approach that you can try and take.
A couple of points on that. So in that case, that beta EFI library actually spits out a HTML report by default. And what we did is we just hooked that up as a build artifact. So for every deployment, you could kind of go and see the set of tests that were run, and it shows all the given when then statements for each feature based on per feature, if that makes sense. The other thing I'd probably say is that it's one of those things where it comes down to education, right? So on day one, with a product owner like that, they're not going to be able to make these decisions, I guess it's up to the team to have a really good bidirectional relationship with them, which any good agile team should have, and sort of slowly give them the confidence and explain this stuff to them, and explain it in terms that they understand, right? If we do this, that means you might have this type of bug. We can fix it within 5 minutes or 10 minutes into production or whatever it is. Are you comfortable with that? If you put it in terms like that, they typically understand it. And especially if you then say, if we test it in this other way where that bug will never be possible, it'll mean that it takes us 50% longer.
It takes 2 days to do that, yeah.
Yeah, it takes us 50% longer to develop this feature. Which one, how much is it worth it? You put it in those terms that they understand, then hopefully if you have the good relationship, then you can kind of, it's not easy, right? And you can't do it from day one necessarily.
For integration tests, when we save our data in actual database, physical one, not a mocking database, we have to create a database for each test.
Yep.
And delete after that.
Yep.
Will be the main slowing factor for running all our tests, because you have 1,000 tests.
Absolutely.
Yeah.
Creating database will be an overkill.
There's a couple of different things you can do.
The question was, if you have to integrate to your database, you may need to spin it up and down in every test. If you have 1,000 of those tests, it can be quite slow. First thing I'd say is, if you go to that top link and you look through that series, in particular the one where I'm reviewing Jimmy Bogard's video, there's a bunch of different techniques for isolating databases that I cover in there, and some of them don't require you to spin up or down a whole database every time. So that's one thing, and then...
Yeah, cool. Well, that was basically...
Right.
So one of those things that you can do, for example, is you can use database transactions to give yourself very similar effects. So spin up a database in basically an empty state, bring it up to whatever schema level it needs to be at, start a transaction, perform your test, and then just tear down that transaction at the end of the test, which is significantly faster. There's a pretty small class of errors that you don't catch with that kind of approach, but again, that's kind of a trade-off. If you've got a lot of that type of test, then that might be a good thing to look at.
If you happen to be using Entity Framework by any chance, that the bottom one there, subcutaneous test presentation, there's some code in that one that has that database test fixture class. I was using my code samples for this talk, and that one has that, but in a way that you can have difference between verify, doing the work, and seeding, doing the work, and verifying, but they're all attached to the one transaction. So there's some like clever little code in there that kind of works. So that's for Entity Framework, but you can do the same thing with like other things as well.
So is there an option maybe to just run a test on a dirty database and just don't clean it?
Yeah, that's the other option. That's certainly one of the ones you can do. You just need to be careful then about the IDs you use in your test and making sure you're not assuming, like in the code samples I had, we were doing things like, cool, pull the single thing out of this thing. You can't do that then. You have to actually look by ID to grab the thing out. But yeah, that's another option, absolutely.
I've got two questions. Quick. The first one is, what happens if one of your clients is running .NET 2.0, for example, and say one of the libraries that you mentioned is supported by 4.0 and so on. So do you guys follow the same approach, or do you guys,
To be honest.
The second one is, how do you approach asynchronous methods, functions running in your project? The same.
Okay, so the first question was, if you've got like .NET 2.0, you can't use some of these cool libraries, what do you do? I'll be honest, I haven't ever used like a project in like just years and years that's less than 4. So like, good luck, but I don't know. I guess, do the best you can, right? Try to find libraries that do support it, or try to, like, why are they using 2.0? God. Yeah, that's not in support, so let's...
I mean, to be fair, there's some of these techniques that you don't necessarily need libraries for, so maybe there's still some things that you can apply.
Yeah. So the second one was around async things.
So if you got full of syncs everywhere,
Yeah.
do you follow the same approach?
Yeah, absolutely. We just, like, say that BD-defy library, that supports async, for instance, so we just make the test, like, given whatever async and stuff, and it would do an await or whatever.
Yeah.
That's fine.
What's your view on giving this unit test to the tester and get involved with it so the tester can actually see and use the different data? Because the challenging bit I see is that most of the tester, like as a developer, I write tests, and the most challenging part is the actual data which breaks the test. And I don't have much time to find out which data would break the test.
Nice. So the question was, how can you involve testers? Because in particular, if you're trying to set up data, then testers are really good at setting up great data to break things, right? I could do literally a whole talk on the role of a tester in an agile team. So I'm going to have to try to
Done that one before,
yep. Okay, number one, developers and testers should work closely together. So if you're writing like a subcutaneous test, pair with your tester. Hey, dude, like help me, or not dude necessarily, because it could be a girl, that's good. No, it could be help me figure out what test data I should set this up with. And hey, which features do you think we should test in this way? Or what should the BDD syntax be? Which scenario should we run? The tester's got a really good mindset for that sort of thing. Sit down with them, pair with them. You're not separate people, you're in the same team, right? And then another scenario we had was we had some testers that actually learnt how to write this type of test, and they were writing some of them as well. Like there's different.
Yeah, which was obviously a lucky scenario, but there's definitely a huge amount of value that they can add just by like sitting down next to you and working together on this stuff. And it may be a bit of a shift in mindset, and again, maybe a bit of training and recoaching to what you've done in the past to get them like helping out in that kind of way.
Cool. Any other questions? Yep, so in the question was, do we use our domain to save objects in the test database when seeding our tests? So yeah, absolutely. In the test that we just saw, in the code samples that we just shown, we were absolutely doing that. In some circumstances, we would absolutely do that, and it works really well. In other circumstances, we might not want to tie that, because you could consider that in some ways to be an implementation detail, and in which case you The only problem with that is you kind of suffer the sort of, like you'd have to call, say, controllers for everything. So you'd have like a lot of duplication between the tests. That has advantages and disadvantages, right? So it's about being pragmatic. Quite often we find that works really well, especially if you use Object Mother and Test Data Builder, because Object Mother and Test Data Builder actually give you a bit of a
kind of an abstraction
layer
yeah.
between you and your domain, if that makes sense. So you're not calling the constructor, you can refactor constructors, all that sort of stuff. You've got constructor calls in one place in your test data builder, for instance. So we find that often alleviates most of the disadvantages at tying it to domain objects. But be pragmatic, right? In some cases it doesn't make sense. In other cases it works fine.
Cool.
Any more, maybe one last question?
Cool.
No?
Feel free to
Thanks,
come
everyone.
chat to us after. Thank you.